Okay, in a previous video, we clearly indicated this, but I'm going to make sure it's stated clearly. For any a and b, where a is greater than 0 and b is greater than 0, that's important because 0 times anything makes it 0, so it kind of makes the whole rule a moot point. But n for the nth power of a times b is the nth power of a times the nth power of b. So, for instance, let me show you where this is useful. Right? If I say I want the square root, and this any root this works for, right, of 4 times 16. That's the same as the square root of 4 times the square root of 16, which is clearly 2 times 4, which is 8. Right? Now, you could have taken 4 times 16 first, and then taken its square root. 4 times 16, 64. Going to get the same answer. Want to prove to you that it does indeed work. And again, it works with variables too, right? So that's the whole point there. Simple example, though, for you. Likewise, for the nth root of a divided by b, that is the nth root of a divided by the nth root of b. So if I had the nth root of the square root, again, using it as an example, square root of 9 over 121. That is the same as the square root of 9 over the square root of 121, which is 3 over 11. And again, you could have, anyway, there you go. Simple example for you. This also works with variables, and that's where we're going to use it a ton.